Alright guys, here we go, 3-3 video. Staying with our inequalities, we're solving inequalities. This time we're going to use multiplication and division. After this lesson I will be able to solve an inequality using multiplication and division properties. A simple inequality. Remember last time we talked what that means? It means it has one symbol in it. One less than or one greater than symbol. Soon we're going to get things that have two. Simple ones only have one. Alright, here we go. So consider the inequality. 4 is greater than 1. Well, 4 is greater than 1. That's true. Does the inequality still work if we multiply each side by 3? Well, let's take a look. So if I start with 4 is greater than 1, and I multiply each side by 3, I would wind up with 12 is greater than 3. Is that true? 12 is greater than 3. That is true. So we're all good to go. What about if we multiply by 2? Well, we start back with 4 is greater than 1, and we multiply both sides by 2. We'd wind up with 8 is greater than 2. And 8 is greater than 2, so that works. So it's still good. So multiplying each side by 2 still worked. Multiply each side by 1. Well, multiplying by 1 is real easy. 1 times 4 is just 4. 1 times 1 is just 1. So 4 is greater than 1. It is. 4 is greater than 1, so that is true. Alright, let's take a look at some other numbers. Now if we multiply by negative 1 and negative 2 and negative 3, what happens? Well, let's multiply each side by negative 1. So I start with my 4 is greater than 1, multiply each side by negative 1, and I wind up with negative 4 greater than negative 3. But that's a problem, because negative 4 is not greater than negative 3. So that's a false statement. So multiplying each side by negative 1 created a false statement. Let's see what happens if we do negative 2. Well, if we start back with 4 is greater than 1, which is true, and we multiply each side by negative 2, I'd wind up with negative 8 is greater than negative 2. Well, negative 8 is not greater than negative 2. So that, again, is a false statement. Same thing will happen here with negative 3. If we multiply each side by negative 3, I'd wind up with negative 12 is greater than negative 3. But the problem is negative 12 is not greater than negative 3, so that created a false statement. So what we see here is that when we multiply each side by a positive number, like we did in the beginning, multiplied by 3, multiplied by 2, multiplied by 1, all positive numbers, the sign of the inequality stays the same. It worked. So it was 4 is greater than 1, multiplied each side. I could keep it going the same way, greater than symbol. However, when I did a negative number, I created false statements. So if I want to create true statements, whenever we multiply by a negative number, the sign must flip to create a true inequality. Basically, this is the only rule you have to remember for inequalities. When you multiply or divide by a negative, you have to flip the sign. So what does that mean? Well, once I multiply by a negative here, I'm going to turn this sign around from greater than to less than, like negative 4 is less than negative 3. Now I've created a true statement. When I multiplied by negative 2 here, I need to flip that sign around. So it would become negative 8 is less than negative 2. So anytime I multiply or divide by a negative, I have to remember to flip the sign. This should be circled about 30 times on your sheet and highlighted and colored with any different colors you got. This is the number one rule you got to follow whenever you deal with inequalities. It only happens with multiplication and division. Multiply or divide by a negative, flip the sign around. Okay, so that's your essential understanding. So we used properties of equality to solve in chapter 2. We can use multiplication properties of inequality to solve as long as we remember to flip the inequality sign if we multiply or divide by a negative number. Positive number stays the way it is. Once you multiply or divide by negative, you have to flip the sign around. Let's take a look at some practice. Okay, what does this mean? X over 3 is greater than negative 1. So x divided by 3, that's what that line means. X divided by 3 is greater than negative 1. Or, fancier, they could write the quotient. Quotient is a division problem. The quotient of x and 3. Quotient of x and 3 is greater than negative 1. So this is a division right here, divided by 3. So in order to get rid of a division, I'm going to multiply both sides by whatever's in the bottom, whatever I divided by. So by multiplying by 3 here, these will cancel out. And all you'll be left with is the top. So just an x. When I multiply this side by 3, I would just have negative 3 over there. So here's my new inequality. X is greater than negative 3. I'm done. I'm all done because I have the x all by itself. There's nothing to divide. I don't have to worry about flipping the sign because I didn't multiply by a negative number. I multiplied by a positive 3. If I look at the picture, x is greater than negative 3. I have an open circle on negative 3. There's no equal sign, open circle, and I would shade to the right because I want numbers that are greater than negative 3. Numbers that work here are numbers like 0, 1, 2, 10, everything to the right of negative 3. All right, a little more complicated. But the first thing I want to do is get rid of that division, get rid of that fraction. So I have negative 3 divided by 4. W is less than or equal to 3. All right, whatever I do to one side, I got to do to the other. So as soon as I have a fraction, I'm going to multiply the whole problem by whatever's in the bottom. That 4 will cancel out that 4 because I'll be multiplying and dividing by the same number. So they'll cancel out. So all I'll be left with is negative 3w is less than or equal to 12. So don't forget to multiply the 4 on that side. So I have negative 3w is less than or equal to 12. To solve for w, I have to divide by that number stuck to the w. So I'm going to divide both sides by negative 3. As soon as I have an inequality and I divide by a negative number, as soon as I say, oh, divide by negative, there should be an alarm in my head that goes off. Alert, alert, alert. Multiply or divide by a negative, must flip the sign. So this has to go from a less than or equal to a greater than or equal. So w is going to be greater than or equal to negative 4. You have to remember that. That's the one thing you got to remember. Everything else is the same as chapter 2. You got to remember that. Closed circle because of the equal sign at negative 4. I want numbers that are bigger than, greater than, w is greater than or equal to negative 4. So that would be the numbers to the right. All right, here we go. Number 3. You got another fraction, another division. That's a division. So in order to get rid of that division, I'm going to multiply both sides by 3. Because there's a 3 on the bottom. So that 3 and that 3 are going to cancel. The only thing I'm going to be left with is negative 1n. Right? That's really a negative 1n is less than negative 3. I multiplied by a positive 3 number. This will cancel that. I'll just wind up with whatever's left here. Negative 1n less than negative 3. Okay, I don't have n all by itself. I have negative 1n. So I have to divide by negative 1. As soon as I divide by negative anything, divide by negative, the alarm goes off in my head. It says, yo, big fella, remember to flip the sign. So now I have n is greater than positive 3. Negative 3 divided by negative 1 is positive 3. N greater than 3. The graph, well, open circle, no equal sign, and I want numbers bigger than 3. So numbers that are bigger than 3, 4, 5, 10, numbers to the right. All right, here's 4. Pretty basic equation. To get the y all by itself, I need to divide both sides by that negative 9, because there's a negative 9 stuck to my y. If I divide both sides by negative 9, the alarm goes off in my head because I said divide by negative. So I'm dividing by negative 9. Once that happens, I got to remember to flip the sign. So y becomes greater than or equal to negative 4. So it went from less than or equal to greater than or equal. Negative 4. 36 divided by negative 9 is negative 4. Here's your picture. Closed circle on negative 4. Shade to the right because you want the numbers that are greater than negative 4. Here's 5. 5x is greater than negative 10. Well, if I divide both sides by 5, there's my alert. But hold on. I didn't multiply or divide by a negative number. I'm divided by positive 5. So that rule doesn't apply because I divided by a positive number. Just because there's a negative number in the problem doesn't mean I divided by that number. I divided by a positive 5. Okay? So I don't flip the sign. So x is just greater than negative 2. So the rule only applies when you divide or multiply by a negative number. So there's an open circle on negative 2. I want the numbers that are bigger than negative 2, which would look like that. All right, couple word problems real quick. You walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? All right, well, let's make an equation. So $4.50 times however many dogs is greater than or equal to 75 because I want to make at least $75. I can make more. I could make exactly 75, but I don't want to make less. So I want to earn greater than or equal to 75. $4.50 per dog. So I'm going to multiply that by the number of dogs. So I got $4.50D is going to be greater than or equal to 75. It's just a simple inequality. Divide both sides to get the D all by itself. I'm dividing by a positive 4.50, so don't worry about flipping. D is going to be greater than or equal to 16.66666666. Okay? Since I can't have 0.666666 of a dog, I better get up to that 17th dog because I want to be at least $75. If I go down to 16, I wouldn't reach $75. So I got to get to that 17th dog. So if I want to earn at least, which is greater than or equal to $75, I must walk at least 17 dogs. So I could do 17 dogs, I could do 18, I could do 20, I could do 100. But I got to do 17 or more. All right, here's number 2. Student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50. What are the possible number of cases the club can buy? Okay, so I can't spend more than $50. Each case is $10.68. So $10.68 times the number of cases is going to be less than or equal to 50. I can spend all 50 or I could spend less. So $10.68 C number of cases, is less than or equal to 50. It's basic equation. Solve it. Divide both sides by the number stuck to the letter. And C is less than or equal to 4.68. Now, I can't get to that 5th case because then that would put me over the $50. So I have to go down to the 4th case. So I'm under the $50. So I could buy 4 cases, 3 cases, 2 cases, 1 case. I really can't buy negative cases. So they asked me for what are the possible number of cases I can buy? 4, 3, 2, or 1. If I only have $50 to spend, the club can buy less than or equal to 4 cases of vegetables. In other words, we could buy 4, 3, 2, or 1 cases. All right? That's it for 3-3, my friends. Hopefully we're getting this. Please come and get assistance if you need it. I'll see you next time. Peace.